Welcome back to the next session in engineering graphics. In the last session, you people have come across about the projection of solids, their introduction part regarding about what is solids and types of solids. There, the major things and the major problems comes in your syllabus is regarding about the prisms and also about the pyramid problems. Last session, I completed one of the problem purely on square pyramid, that is resting on one of its edge condition. In today's session, let us know about the square pyramid resting on corner condition and axis inclined to both HP and VP at different angles. The last session, the base edges get inclined, base edges get inclined, and that base edge, the resting edge is get inclined to VP with the given angle. Means there no need of finding out the beta angle. In this problem, let us know about how to find out the beta angle, why beta angle to be identified, to draw the last position at the in the last position, that is nothing but the third position in HP and VP. Now I am going to read the question on square pyramid. Here I have written the question over it. A square pyramid of 35 mm sides of base and 65 mm axis length rests on HP on one of its corners of the base. Means for us here the square pyramid of sides 35 mm sides of base, it is very much important, and 65 mm axis length is very much important for us. Rest on HP, it is resting on HP on one of its corners. They are clearly saying it is resting on one of its corners of the base. Means in this problem, if I consider the square pyramid, in the square pyramid the base will be there. It is bounded by four triangular faces and get connected at the apex point or the vertex point. In the square pyramid base, in the problem they are given, it is resting on one of its corners of the base, whether it is resting on this corner or this corner or this corner or this corner. Means in four different corners were present over here. In one of the corners, the square pyramid is resting on HP. That will be clearly understood in the second position, but before going for the first position, I will going to keep the object like this, which is resting on corner. In the last session, I kept the object like this, it is resting on one of its edge. Now I am keeping the object diagonally, it is resting on corner condition is proved in the second position. Now till there it is resting on one of its corners of the base, I will go for the solution. First thing, I will go for drawing the XY line. This is my XY line. Now it is a square pyramid resting on corner condition. I am going to draw in a square of sides 35 millimeter of sides resting on corner condition. You people already come across how to solve the problems in planes about resting on corner condition, on especially on square lamina. There you people have come across it, how to draw the square lamina. Okay, this is the square lamina resting on corner condition. Now when it's come to the I am showing the dimension of it. Now I will go for giving the namings for the corners and for the axis. Now in the resting on edge condition, in the last problem you come across this square pyramid is resting like this, then in the second position we tilted the object like this. There the all the corners and the slant edges are clearly visible for us. Here also the same thing, even it is resting on corner condition, it is resting on corner condition. From the top view, all the slant edges and the corners are clearly visible. Because of that, I have written in the color lines. I am darkening the edges and the slant edges that are get connected to the square pyramid. Now the first position is over. The next thing is about, I need to go for drawing the projection lines to the top to get the front view of the object. I am drawing the projection lines. Now here in the next condition they given the axis length of 65 mm, means axis length, but here the axis is not visible for us because one of the slant edge is overlapping the axis. One of the slant edge is overlapping the axis. That slant edge is nothing but from O to B is the slant edge overlapping the axis. Axis is directly connected from the vertex to the center of the base. Now I will go for drawing the thick line of length 65 mm. Next I am connecting this slant edge, one of its slant edge. Now I will go for showing the dimension of this axis. Axis is present here actually. Now this is A dash, this is B dash, in bracket D dash, because this is the hidden corner that is not clearly visible for us. And one more thing, O1 dash, because for the axis from the top of the vertex we are going to call it as O, to the bottom we are going to call it as, that is get connected to the base part exactly at the middle, we are going to call it as O1. This is O dash and this point is C dash. This is the solution for the first position. Next, when it's come to the second position, to draw the second position, you can observe that I'll go for reading the remaining part of the question, such that the two base edges containing the corner on which it rests make equal inclinations with HP, full stop. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degree. This is very much important for me, 40 degree, and to VP at 30 degree. Means in the second position they clearly saying that the projections of the pyramid when the axis is get inclined, means in this case the axis condition they given instead of giving the edge condition. Means in the last problem the resting edge is get inclined at an angle of 45 degree, but in this problem they are clearly saying that the axis of the square pyramid is get inclined at an angle of 40 degree to HP. Now how to draw this 40 degree to HP for this the axis case? When it's come to this problem, in the last problem also we already know that the axis will going to present here from O dash to O1 dash. So this is my axis line, but here visible edge is overlapping the axis, but axis is present when it's come to the virtual view of the object. It is a projected view of the object. If I keep the object in front of the observer in a physical manner, there the axis is definitely present. Though now after projecting the object, the axis is not clearly visible for us. We know that this axis line is at an angle of 90 degree with the base part, 90 degree with the base part. By knowing that concept, 90 degree minus 40 degree will going to give an angle of 50 degree. Means we need to incline that base edge to an angle of 50 degree. Now I am inclining this object to an angle of 50 degree by keeping the C dash corner on HP. Means here I can go for keeping the A dash or C dash, because in the last class itself I told you people about that I can rotate towards my right or towards my left. They are not clearly mentioned in the question which corner should be placed on HP. For the easy construction and for the space utilization in the graph sheet, I'll go for keeping the C dash corner exactly on HP. Now to construct that, I'm going to measure this length with the help of the scale. I'm going to draw a line inclined at an angle of 50 degree with reference to HP. Now I draw a base which is get inclined at an angle of 50 degree with reference to the HP. I am going to call this point as C dash, and at exactly I am going to measure it from C dash to B dash or from A dash to B dash. The length will going to remain same. I am going to call this point as B dash comma D dash, and one more thing, O1 dash. Now to get the remaining part of the solution, I am going to measure from A dash to O dash or from C dash to O dash, because the slant edge will going to remain same, length of the slant edge will going to remain same. Now with the help of the compass, I am going to cut an arc over here from C dash to O dash length. Again from A dash to O dash I am cutting the arc. Next part I will go for joining the lines from A dash to O dash to A dash and from O dash to C dash. This is this object inclination with reference to the second position. Now this point I am going to call it as O dash. Next thing is about, I will go for drawing the visible edge, one of the visible edge. I draw the visible edge. Next part I will extend this to the remaining part. Now if I measure the angle, this will be the exactly 40 degree. Means for construction purpose, first I rotate the base to 50 degree. How I am getting the 50 degree? Based on right angle triangle inclination, means this visible edge overlapping the axis is get inclined at an angle of 90 degree with the base. Based on that 90 degree minus 40 degree given angle, I am going to get 50 degree. I rotate that base, the remaining part of the angle is nothing but 40 degree. Next, to get the second position in the top view, I will go for drawing these projection lines from the top. I am drawing the projection lines. Again from B dash D dash point I am drawing the line. Again from C dash point I am drawing the line. Next from B I am drawing one more line. I will extend this line to this point. Next from O dash I am going to draw one more projection line. Now I will go for the naming the points. This is A, this is B point, this is C point, this is D point. Now here the O1 will going to appear. This is my O point. Now I am going to apply the concept of visible and invisible concept. Now the first condition about that visible and invisible, identifying the visible and invisible edges is nothing but outer line edges or outer line boundaries are clearly visible for me. I am going to start from A point. This is my outer line edges. Next I will move to O point. Next I will move to D point. Next again I will come to A point. Okay, this is my outer line boundary edges that are clearly visible for me. And the next second condition is we are viewing the object from the top view. Means here the observer will going to view the object. According to that condition, the edges and the faces near to the observer is clearly visible. Means according to the observer, OA, OB and OD is clearly visible. OB and OD is already visible for us according to the boundary line condition. Next, OA is the only edge that is left. I have written that. Next, after that, one more condition is there. Above the axis, all the edges and faces are visible. Above the axis or exact to the axis, O dash to A dash is clearly visible for us. O to A, O to B is visible, O to D is visible, and the only edge that is not visible, two edges that are not visible is nothing but that is get connected with the resting corner. Those two edges are not clearly visible. That is nothing from C to B and C to D is not clearly visible for us. Now, according to the visible and invisible edges concept, I explained how to write the top view of the object. First condition is outermost boundaries are clearly visible. Second condition is observer viewing the top view. In that case, faces and edges are near to the observer is clearly visible. O dash to A dash is near to the observer. O to B is near to the observer. O to D is near to the observer. It is clearly visible. The only remaining part is nothing but the resting corner, two edges that make equal inclinations, those are not visible. Now the object is like this. If I view the object from the top, this triangular face is completely visible. Again, one more triangular face is visible for me in this side, that is clearly visible for me. Means now this is the position of the object exactly at an angle of 40 degree to the HP. And the last condition is the axis is get inclined at an angle of 30 degree to VP. Now here they are given that axis inclination, but you can clearly observe that the axis length in the first position is 65 mm. If I measure the axis length in the second position top view, the length will not going to remain same, it will get changed. For that purpose, we will go for finding out the beta angle. Means in the last problem, it is resting on edge condition, but you can clearly observe that the edge is get inclined to this position like this. In the next case, we are keeping the edge on the HP itself, but we are rotating the object like this to make an angle of 30 degree with the VP. Means the resting edge length will not going to get diminished physically, but here while on the representation, the axis length is getting changed from first position to the second position. First position top view length is 65 mm. Second position, if I measure, maybe I am going to get 48 millimeter or around it. Maybe I am going to get 48 mm in the second position. Now I am going to measure this axis length. I am getting 48 mm. Means the length is getting changed here. To overcome this, I will go for finding out the beta angle. Means we are finding out the apparent inclination because the length of the axis will not going to remain same till the last position projection in the top view and also in the front view. It's clear. In the last problem, in the edge case, the axis, the edge length will going to remain same till the last position. Means if the length of the edge or the axis remains constant till the last position, we will not going to find out the beta angle. If the length will get varied for that particular edge or the axis, then we will going to find out the beta angle. Now, first I am going to consider the first position axis length of 65 mm. I am going to draw a locus line here of 65 mm length. I am going to draw in a line inclined at an angle of 30 degree. I am drawing a line inclined at an angle of 30 degree. This is my first position axis length. Next, I am going to draw one more locus line at the end of the line. Again, I will come to the second position top view. I am getting 48 mm over here. With the compass, I am going to cut an arc. I am going to join this. I am going to get the beta angle of 41 degree. I am getting the beta angle according to my representation of an angle of 41 degree. Now, I will come to the last position in the third position top view. I am transferring this second position object here, not the first position object. I am transferring the second position because the object is kept like this. Now it is get inclined at an angle of 41 degree to VP. Now I am tilting the object to make an inclination with reference to vertical plane at an angle of 41 degree. If I consider this board as in a vertical plane, now my left hand as an horizontal plane, I am rotating the object 41 degree exactly to the vertical plane, whatever. Okay, after finding out the beta angle to draw the last position of the square pyramid, I will go for the construction exactly at an inclination of 41 degree in the top view position in the last position. First, I will go for drawing an axis length inclined at an angle of 41 degree. This axis line, what I am drawing here, there should be a thin line inclined at an angle of 41 degree. I am just extending it. Next, I will go for mentioning the angle 41 degree. Now I will come to the second position top view. I will measure the length from O to A. O to A, I will going to measure the length. I will mark the point over here. This is the O point and this is my A point after measuring the length. Next, whatever the representation I have written in the dark color, the same should be copied here or should be transferred here. Now I need 3 more points to complete the diagram. To get that, I will go for measuring the sides by side length or from the slant edge length. First, I will go for measuring from A to D or from A to B or from A to C. First, I will go measuring from A to C. After measuring from A to C, I will going to mark a point here. This is my C point. After completion of C point, I will go for the points D and B. For the D and B, listen here, from A to D, from A to C, the length will going to remain same. Again, if I measure from C to B and from C to D, the length will going to remain same. One time measurement is enough. I will measure from A to D measurement. I will come here with the help of compass. I will going to cut the R from A to D. Next, I will come to the C point with the same measurement. I will going to intersect this arc. Again, I will come to A point. I will going to measure from A to D. I will going to cut the arc. Again, from D point, I will going to intersect this arc. Once after completion of this, I will go for joining from A to D and from A to B. Next, with hidden edges, I am connecting the C points. Again here the same thing, because those two edges are not clearly visible for us from the top view of the object. Next, remaining slant edges are get connected to it. Once after completion of this, I will go for naming the points. This is A, B, C and D points. Next, for the O1 point, that is from O to O1 or from A to O1, I am going to measure it. I am going to mark it the O1 point. That is my axis point. This is the final position top view of the object. Next, I will go for drawing the projection lines from the top view to the front view to get the final position of the object. For that, from all the points, I am going to draw the projection lines. From D point, I am extending the projection line to the top. Again, from B dash and D dash is present in the second position top view. I am extending the line. Again, from A point, I am projecting the line to the top. Again, from A dash, second position front view, I am projecting the projection lines. Again, from C point, I am extending the projection line. Again, from B point, I am extending the projection line to the top till where it will going to meet the projection line from the front view of the object. Now, I will go for naming the points. This is D dash, this one is A dash, and this point is C dash, and this one is B dash. Next, I will go for extending this O to the top. Again, from second position front view, I am extending the projection lines. If I write the arrows, these are the directions of the projection lines. Similarly, to avoid confusions, I am showing this. Now, this is my O dash point. Now, again I will go for applying the visible and invisible concept. According to the first concept, outermost edges are visible or outermost boundary lines are visible. According to it, if I start from A dash point, A dash to D dash is the outermost edge, D dash to C dash is the outermost edge. Again, from O dash to C dash is the outermost edge. Again, from O dash to A dash is the outermost edge. This is the outermost edge that is clearly visible for us in the front view last position. Now, the second concept is to the observer, the faces and edges near to the observer. If I mark a line, means this is nothing but the arrow shows you people are observing the object exactly in the front view of the object. From that, if people visible the object, the base edge is clearly visible. Means the base edge is clearly visible. A, B, C, D is clearly visible. Already A dash, D dash and C dash is clearly visible. If I connect from A dash to B dash to C dash, again from A dash to B dash, now it is clearly visible for us. Okay. Once after completion of this, one more edge that is clearly visible for us from the second concept, that is nothing but O to B is clearly visible. For that, I will draw the projection line from O to B, O dash to B dash is clearly visible. And the last concept is below the axis, whatever the slant edges and whatever the edges and whatever the lines that are present, that is clearly visible. According to it, O to B, O to A is already visible, and the only slant edge is not clearly visible for us is nothing but O to D. That is nothing but that should be written in hidden lines. because this O to D is opposite to O to B, that is that is completely not visible for us, because it is overcome by, and it is already it is towards the axis. When it's come to the projection, it is towards the axis, because here OB visible edge is overlapping the O to D hidden edges. Because of that, it is not clearly visible for us. And the last point that is left is nothing but from O1 to O1 dash. I am drawing the projection line. Now this is not visible for us. If I draw the axis representation to it, this is the final appearance of the object in the last position. Means when the axis condition is given in any of the problem, in similar case they will going to change the question for pentagonal pyramid and hexagonal pyramid. In hexagonal pyramid also they will going to ask the edge condition and axis inclinations, and also in pentagonal pyramid they will go for the same. They will go for asking the edge resting on edge condition and resting on corner condition. But whenever they are given axis inclined to both the planes, during the time if the inclination they are given with respect to HP and VP at different angles, in some of the problems they clearly mention the condition that the axis will going to appears to be inclined to VP at 45 degree or 30 degree. It means they already given the apparent inclination in the final position of the object. During that time, no need of calculating this beta angle or the apparent inclination. They already mentioned in the question. The problems are similar for pentagonal pyramid and hexagonal pyramid. Means in this case, you can clearly observe that they given the square pyramid resting on one of its corners with base sides of 35 mm and axis length of 65 mm. And next, in the last condition, they given the axis get inclined at an angle of 40 degree to HP and 30 degree to VP. I clearly explained how to do the construction and how to do the beta angle construction. This is the final appearance of the object. Thank you.